Hello, folks. Welcome to another NDC Sydney. Again, virtual. Hopefully, the next one will be in person, and I'll see you face to face. Have a bit of a chat, conversations happening. We have delicious food and drinks and everything else. But meanwhile, let's talk through Azure and containers. So in this talk today, we're going to talk about different ways that you can use Azure services to run your containers, not just in Azure, but also on your on-premises environment, on other cloud providers, and on your local system. So we're going to cover quite a few different services. If you have any questions, feel free to put them in the chat. I'll monitor, potentially answer those during the demos while we're waiting for stuff to happen, or we'll leave it at the end. At the end, there's also a short quiz, and based on who answers fastest, we will put or we will select some people and give out some swag on behalf of Microsoft Australia. All right. So before we start, let me just give you a bit of an intro about myself. My name is Yas. I'm a developer based in Melbourne, Australia. I'm at the moment working as a technical trainer for Microsoft on Azure, and I'm really happy to be here presenting this particular topic to you, since this is one of my favorite ones in terms of the services that we have. So just to set some ground rules, we are not talking about containers, how to create them, best practices. All those stuff have their own place, not in this particular talk. And we are also not talking about how to create resources in Azure. Again, this is not an Azure training. So we just wanted to give you some basically threads and some starting points so you can go and investigate these services that I'm just going to cover today in a bit more detail, and hopefully they will help you to set up your solution, whether it's your hobby, local environment, or just development testing purposes, or if it helps you in your production environment, then that's going to be awesome as well. So containers, folks, are getting really popular. They're getting widespread. Everybody is using them, from local development, testing, from production, workloads. All of those are getting more and more, and people are creating these containers, maintaining them, and running them within quite a few different environments. And Azure as a cloud is not an exception. So there are many different ways that you could use Azure to run your containers, and we're going to cover some of those today. Now, historically, we only had support for DCOS and Kubernetes, and this was generally called Azure Container Services. It was the first iteration of our services in Azure, and it was mainly used by fairly advanced scenarios. It wasn't really suitable for development. It wasn't really suitable for, small-scale applications. But then we realized that people are shifting towards containers, and we sort of doubled down on it. And that basically paid off. So at the moment, I can proudly say that Azure is one of the most advanced, or has some of the most advanced services which you can use, specifically in terms of PaaS, or platform as a service offerings, which helps you to just run your containers and not worry about any infrastructure or background of what is happening, and updates and patch managements and security and a whole bunch of different stuff. So if you wanted to go through a journey, right? Today's talk is about going through a journey. We're going to start very simple and very basic, and we go towards more advanced topics at the end. So where do we usually start? Well, if you want to work with a container, you're going to have an image, and generally you need to store that image in some place. Historically, you could set up your image repositories in Docker Hub as a public repository, or you could use a private repository hosted somewhere. But Azure has a really great service which is called Azure Container Registry, or ACR in short, which allows you to store your images in Azure with ease, without really hiding or abstracting those complexity of working with these images, and making sure they're secure, and a whole bunch of other features that I'm just going to cover shortly for you by default. So this is a private repository. And the advantage of this over other repositories such as Docker Hub, or even the privately hosted repositories, is its integration with existing Azure services. So you can set up, for example, Azure policies to disallow or prevent people from pushing images that have security vulnerabilities, or you could perform some sort of scanning. You could set up CI/CD pipelines using this particular service. So really great integration with quite a few different services, Azure Active Directory integration for authentication and authorization, and a whole bunch of different features when it comes to pricing points. So if you go with basics, generally you get less features. If you go with standard or premium, you get more features. Some of these features are, for example, VNet integrations. If you wanted to access your image repositories or image container images within your virtual networks, or geo-replication, if you wanted to basically replicate your images across multiple different parts of the world for different purposes. It might be for disaster recovery purposes, or it might be for high availability. It might be for just ease of access, and whoever's closest, they will get the region closest to them. So regardless of what your scenario is, Azure Container Registry allows you to set up those high scale environments, and it will give you really great service and great speed when it comes to pulling and pushing images into this particular service. Now, some of the use cases for when to use this, if you want to have a private image repository, this is your friend. It's really easy to set up, and we'll see in a minute in a demo. It's really great for integration with other services. So variety of services which can run containers, they already have integration with container services and with container registry. And we'll have a look at quite a few demos today, and we'll see how we can simply pull that image from this service. And the good thing about this is that because if you're running your containers in Azure, you don't even need to have any credentials anywhere. So you could just use managed identities to access these resources and pull images and push images from other resources in Azure. You could perform security audits on images to basically ensure that your images are secure. There is no vulnerability. There is no security hole within your images. Specifically, if you have multiple different teams running or creating and pushing these images from not just only within your environments, but also outside, such as vendors and third parties and other stuff. And developer tooling integration is pretty cool as well. So you have VS Code integration, you have Visual Studio integration. You could use Azure CLI, Azure PowerShell in your local terminal, or even in Azure Portal in Cloud Shell, and a whole bunch of different services which allow you to work with this service to pull and push images into this repository. So let's go and have a look at demo. Let me just bring up this up. So before I continue, let me know if the font size is good. If you want me to increase the font size, let me know in the chat so I can increase it a bit. But if you can see everything, and let me just open up this particular file up so that you can see the font here. So hopefully the font is clear and you can see everything clearly. We have a Node.js application that we wanted to create an image from, all right? So this Node.js application is nothing very specific. It's just a simple application which has an HTML, a bunch of images, a bunch of CSS. We're just simulating how to create the image. Now, for any container, specifically if you're working with Docker, you're going to have some instructions which tells Docker how to create your images, and that's usually stored in Docker file. So here's an example. We have a from statement which specifies our base image, and then we have some working directories. We are running some commands within that particular image to run, npm install the packages, copy our files within that container, and set up an initial command for our container. So when the container is starting, this will be the command that is going to be running within our environment, right? So we're going to go and run this particular file. So let me just quickly open this in a new terminal. Not that, wrong option. And here, all we need to run is docker build -c/tag, which we just call it a Ninja Cat. Specify the path to our Docker file, which is dot for current directory at the moment. Before I run this command, I need to start my Docker desktop. So Docker desktop is a software that you can start or install on your system, and it allows you to run Docker commands locally for your environment. So let me just quickly bring that up. If you don't have that, if I try to run this command now, I should get an error because Docker is not running on my system. So there you go. The daemon is not running, so we need to wait for that Docker desktop to start. And when it starts, we should be able to run the command this time successfully. All right, so it seems like the Docker desktop is starting. All right, so let's see if I run the same command again. This time it's going to be, all right, not yet. Still getting started. All right, so wait for a few seconds. Hopefully. All right, so now the Docker is running. You should be able to run the command this time. And you can see that it's getting the base image. It's basically running our commands, running npm install, copying all the files, and we have an image stored locally that we can use and push that image into our Azure Container registry. So just to show you Docker desktop, this is the Docker desktop. And if I come into our image section, you can see that our NinjaCat image is now here with the tag latest. So I didn't specify any particular version. I could have, but I just put it as latest because this will simplify our mini CI/CD pipelines, which we have later on in our Azure services. So again, just to sort of bring up that, we're going to use this file, open it in terminal. And this time, I'm just going to call this NDC Sydney. So I have a resource group called NDC Sydney in Azure Portal, and I want to create a new Azure Container Registry within that particular resource group in Azure. So first of all, we need a name. I'm just adding a random name. This name will be part of the domain name, so it needs to be globally unique. So if I run these 3 commands now, we have some variables, and all I need to have is to run AZSR create, and I'm using Azure CLI here to create that basic Azure Container Registry. I've already authenticated to Azure. If you haven't done it, you have to run AZ login before this. So this will now go and create a new version of Azure Container Registry for us, and we can then go and push our images into our container registry. So while that's happening, let me just review what do we have here. So first thing first, we're going to log in with that container registry. There you go. I think the container registry just got created. All right, so here you can see that the container registry just got created, subscription information. This is the URL of that container registry, etc., etc. So that container registry is now up and running. So first thing first, we need to log into that container registry. So using that, we just log in, and that allows us to push images into our container registry. So normally, if I want to push my image into container registry, I need to run 2 commands. I need to run docker tag obviously after I run docker build to tag this image with the URL of the container registry plus the repository name that's going to be created that image in. So once I tag that, then I can use docker push, and this will push my images up into my container registry. However, we have this command here, AZSR build, and it basically does all those 3 actions at the same time. So it builds your image, it basically tags it and pushes it into our container registry. So if I now run this single command here, this is now, let me just see what's going on here. So I'm just going to do that. Let me just bring this Azure ACR and here. All right, so I'm just going to run that. What this does is creating that image, tagging it, and pushing it into my registry. It's going to be fairly fast because I've chosen a really slim Docker image as my base. So it's going to be fairly quick. If I bring up Azure Portal here, this is our resource group in Azure. So I've already logged in. I'm in my tenant, and you can see the Azure Container Registry created here.
Why are you telling each one?
Folks, please stay on mute just to make sure that we are not hearing echoes or And you can see here at the moment, I don't have any repository, I don't have any images, but that's because we are already pushing that image up. So if my internet connectivity helps me to push that image up, this is going to be fast, and hopefully, there you go. And there you go. So now we have our, I come back to Azure portal, I should have a repository. There you go. This is our Ninja Cat, and this is our latest tag. So this image, we're going to use that image later. Just to showcase how easy it was to basically create an image and create a service, create a container registry, and push that image up. And to show you some really basic, features, you can see the access key. So if you wanted to use a service, let's say Azure Container Instance or Azure App Service or whatever else that we want to run the container, we're going to have to come here and enable this admin user. So that will give us a password, and we can use this in our CI/CD pipeline. We're going to have a look at that in a second. You can see here the identity, if you wanted to enable identity and allow people to use that. Networking, so if you wanted to basically restrict the access to this repository from your virtual network, you're going to have to first upgrade to a premium SKU and then enable the firewall rules to enable that particular functionality. And you can see here some security settings if you wanted to go and figure out whether you're complying with your requirements, etc., etc. There are some webhooks, so you could basically call a webhook on some events that are happening, and these are really cool features of Azure Container Registry. So now that we have our image, it's time to run that particular container somewhere, right? And we start with Azure Container Instances. That's the fastest way you can run a container in Azure. It's a really slim and, it's really good for small scale applications. It's meant to be generally used for development, testing purposes, or even in production on small scale applications. It's got some, so when you create this particular resource, you have some options. You can specify how many, number of vCPUs you want to have, how much memory do you need, etc., etc. But once you've done that, it just runs one container for you, and that's it. All right, so really great way to get started. Now, sometimes your application is a bit more complex, but you still want to run it in a container. Let's assume that you have a web application and you have a Windows application. So this is your web application, then you have a database. So this is, let's say, a MySQL or SQL Server, whatever it might be. And you wanted to run these two applications or these two services within the same container space. So you could use the container instances, a feature which is called container group. Using container group, you can run these two containers within the same container instance. You can make one public. So let's say this web is exposed to the public, and then the SQL server, it just exposes a port which is going to be used by the web. So that would be, for example, 1433. And the web can access SQL. The SQL isn't exposed anywhere outside, but it's really great because you can still run your applications within a container in Azure very quickly and very efficiently. So that's a really great feature. Azure Container Instances also has a VNet integration. So if you have a virtual network, you can definitely leverage that feature. But again, this is a managed service. So you don't manage how the virtual network is run, etc., etc. You can enable that if you go to a higher pricing tier. So let's see some of the use cases. As I said, if you want to run a single container, then this is a great place for you to start. If you are a developer, I highly recommend you start here and then work your way up through more advanced scenarios. No need for integrations with other services such as VNet. If you just want to, have a container expose it, externally through internet, through a domain name or public IP address, this is again a great service for you to get started. If you want to run multiple containers in a group, which basically allows you to share the same infrastructure between those containers, again, this is a great feature that you could use. So let's try and create that, but this time we're going to go through Azure portal, not through Azure CLI. So if I come back to my resource group, I can click create new resource, and here I will specify I want to create a container instance. Check sure The publisher is Microsoft. I will click create. Here you can see that the subscription and resource group is already automatically selected. This container name is not part of the URL, so this doesn't need to be unique. So we call this NDC. And then the location. So if your location supports, for example, availability zones and you go with premium pricing, then you can obviously select those features later on. Now, in terms of the image source, we're going to come back to this in a second, but let's go and have a look at the sizing. So changing the size, you could go from 1 to 4 CPU cores. You could go from 0.5 to 16 gigabyte of or gigabyte of RAM. So that's the limits that you have with this particular service. And if your region supports GPU, you could potentially use GPU based on the region as well. So at the moment, I'll leave everything by default. Let's come back to this source. So we're going to run a container and we need an image for that. And we just want to use that container registry that we just selected. And I haven't done anything. I just click container registry. It automatically detected that I have this registry available. It automatically detected that there is an image available and a tag. So I can just simply go there and run this container. And this is a Linux-based operating system for me. I can select the networking rules here. So if I wanted to, I could just basically use a domain name. So this is, let me just see, and this is it. That should be good enough. You could play around with the firewall rules, make it private, make it public, however you like. What ports do you want to expose from your container? So at the moment, we only have port 80. Definitely you can enable port 443 or other ports if you want to. And for advanced settings, you could set up restart policies to be on failure or always or never. You could pass in some environment variables from here as well. And you could also override the starting command that we had in our Docker file. But let's go and create this Azure Container instance, and that basically creates an instance of our container, and it can run it really quick, really fast. So let's see, there's a question here. Can we push the image from local to ACI without pushing to registry? No. So you need to have a source for your image if you want to work with ACI. So you need to store it in either a container registry, in Docker Hub, or even in a private repo, but you definitely need to have that. And I'll show you when the service is created and started up, I'll show you what I mean by going through the deployment center, which is available. So that's like a mini CI/CD pipeline, which we've set up for you. All you need to do is provide the source, and we set up the rest of the stuff for you. So even if the image gets updated, you can go and get the latest version always regardless of what's happening. So if I run this here, we should see our application up and running. There you go. We have our NinjaCat application. There's nothing specific to this app, but this is how fast you can run your container in a container instance from your container registry that we just set up. So everything that we've discussed, this is roughly about 5 minutes or so, and we already have a container up and running. You can have a look at the containers here. So this container is running. You can have a look at the logs of this container. You can have a look at or you connect to that using SSH. You can have a look at the properties of the container, all the ports, environment variables, etc., etc. It's a really great way for you to work with container instance. It also has great integration with Azure Monitor, so your container logs could be easily routed to Azure Monitor as well. Now, this is a very, very simple service at the moment. By default, we don't support custom domains for this particular one. However, you could use Nginx and set up custom domain if you wanted to as well. So that is available, but not through the Azure default features. You need to set that up yourself. Anyway, so this is how easy it is to run a container instance. And if I have a look at so when you create this URL for your image, sorry, let's come back here. This URL for your image here, you cannot update this after you created your container instance. If you want to change the image, you need to recreate, or you need to basically send the same command that you ran through Azure CLI or Azure PowerShell to recreate the same using a different URL. So it basically technically doesn't recreate the service, but it updates the URL. The team is working on it to add that feature here to be able to update the image afterwards, but because of the way the service is sort of created, you can't update the image from Azure portal at this point. So these are the limitations of this service. Now let's move on to a more advanced scenario. So let's say you have now a container, you want to run it in Azure, but your container needs some more features than you generally have with the container instance. As an example, let's say you have some resources on your on-premises environment. So your database is sitting on your on-premises on a VM, and you wanted to access that from your web applications, which is running in a container in Azure. So for that reason, you need hybrid connectivity. And for that, you can use Azure ACI. Technically, you could use VM integration, etc., but it's not straightforward. So you have to go through a lot of steps to be able to establish that connectivity. So Azure Web Apps for Containers is generally the same service that you were using, app services that you were using to run your applications. And it's already supported quite a few languages such as C#, Node.js, Python, Ruby, etc., etc. But now you can run containers in Azure. So in terms of Azure Web Apps, when you run a container, it will benefit from the same features that you already have. So we need integrations. It can have hybrid connectivity using the Hybrid Connection Manager, which uses Azure Relay. It basically has whole heaps of different features such as auto scaling and a whole bunch of other stuff. So really great if you wanted to run your container as a, for example, enterprise-grade application and leverage from the same advanced features that Azure App Services offer for you. The integration with your CI/CD pipeline, whether you're using Azure Devops or GitHub, is really easy to set it up, really easy to create that image in your build pipeline, push it to container registry, and then deploy it into either the container instances or web apps, really easy. And you can have like different, for example, events to use that particular, trigger that particular CI/CD pipeline as well. So the use cases for this particular one, if you wanted to containerize web applications on Azure, this is a great place for you to start. If you want to have, for example, auto scaling, load balancing by default, again, the Azure Container Instances doesn't have those features. So you need to upgrade to a web app. If you wanted to deploy in seconds using any of your favorite tools, Azure DevOps, GitHub, Azure Container Registry, Docker Hub, etc., etc., again, this is a great place for you to start. And we'll have a look at this in a second as well. High availability. If you want, you can enable high availability for your web application based on the pricing tier that you have. And when you have that scaled out application, automatically the load balancer kicks in and routes the traffic between different containers based on the round robin algorithm, and then you're good to go. You don't need to worry about the updates and patches and everything else. This is again a PaaS offering which helps you greatly to just focus on what the delivering value to your customer and not worry about what is happening in my infrastructure. App Insights, analytics integrations, again another feature of App Web Apps. If you're on a container there, you could use Application Insights, you could use the analytics to find out what is happening within your container, really with little or no coding or configuration at all, depending on obviously the operating system of your choice. So let's go through a demo for this one. Now, I've already created a web application. If I come and have a look at this web application here, this web application at the moment is running a container, but that's just the default Nginx container, and we're going to go and configure this app to use our image that we just created in our container registry. So if I come to this deployment center here, this is a great way for you to configure the source of your images, right? This is that mini CI/CD pipeline that I specified earlier. You can see here the source can be a container registry, it can be GitHub Actions, it can be Azure Pipeline. So all of those can be the trigger point and the source of images that are going to be pushed into these applications. Then you have the container type. Again, this is a bit more advanced than the container instances. You can have a single container or you can have a Docker Compose, which is in preview. So I don't recommend to use that for production purposes, but it's a great way for you to get started before the item or before this feature goes to GA or general public availability, so that you familiarize yourself and you can run multiple containers easily in a web application. The registry type, this could be a Docker Hub, this could be a Azure Container Registry. At the moment, this is a private registry. I'm just going to change that to Container Registry. And you can see here, it will basically bring up my registry. Once I select that, it will bring up my image and it will bring up the tag, and I can go and configure this here. If I save this, this is now going to go and fetch the image from this repository and run it in our container. So if I have a look at the logs here, you can see the image is being pulled. The container is going to be running our applications. And at the moment, there is no logging enabled because I've disabled the logging just to be a bit faster. But this is now up and running. So if I come back into my application and bring this up, and if I get rid of the cache right here, you could see that. Here, grab this and bring a incognito window just to be, no, hasn't kicked off yet. So let me just see what's going on here in the logs. All right, so it seems like, yeah, there you go. So it's doing some stuff. Image, okay, got you. So if I come into this URL, and I need to look at port 80, not port 80, 443. So we were looking at the wrong port here. So you can see the application is running. It was very fast. It was very optimum. If I update my image and push a new version into my web app, it will automatically get updated through the deployment center. So I don't even need to worry about the next version of the image that is going to be pushed into my service. All right, so now let's go a bit more advanced. So we've basically come so far. Let's review what we've done. We've created a registry, we created an image, pushed that image into a registry, and now we've started with very basic settings with using Azure Container Instances. And now we've moved to a more advanced scenario where we run one or multiple containers using Azure Web Apps. Now, what if you have long-running tasks? What if you have something like a report that you wanted to run every day at the end of the day, or every week, or whatever it might be? Or what if you have a bunch of processing units which need to run at scale and need to basically run for a long period of time? Azure Web Apps or container instances are not really good candidate for this purpose. You could use Azure Batch plus Batch Shipyard, which is a new feature added to Azure Batch, which allows you to run a container at a scale to basically handle your workloads. So these are long-running task reports, etc., etc. It's really got good integration with some really cool dashboarding like Grafana, Prometheus, and a whole bunch of different stuff. You could easily go and set this up, and it will show you what's going on within the entire ecosystem of your container. So how many number of containers you have running, what's the CPU percentage on them, the memory usage, the total memory average, how many number of nodes do you have, etc., etc. A really great way for you to go and leverage sort of like a background processing or long-running tasks, which previously you used to run using, let's say, web jobs or with those type of features in your Azure services. Now, in terms of the use cases, if you have big data workloads, you could definitely use this to scale out your containers and handle a large volume of data which needs to be processed at a particular point in time. You could also use that to generate reports at the end of the day, at the end of the week, monthly, whatever it might be. You could use this to basically run long-running tasks within your containers. And if you have CPU-intensive processes, again, this is a great way for you to leverage that particular. So again, if you use web apps, you probably get away with scaling out the instances, but you pay a lot more for, and you don't have this capacity that Azure Batch will offer you. And the next service we will go through is Azure Service Fabric. Now we're coming out of that particular trend that we were so far. Now we're talking about more of an orchestration services. So these are services that allow you to run multiple containers, orchestrate them, make sure everything is good, monitor their health, set up CI/CD pipeline, DevOps, auto scaling, always on, a lot of different features that basically are offered using these services. So why do we start with Service Fabric? Well, if you already have a Service Fabric instance running at your on-premises environment or even in Azure, and you have some sort of a mock services setup, you could then run containers side by side with your mock services. So this is a great way for you to introduce containers or start migrating your existing applications which are deployed to Service Fabric into containers. And then once everything is done, you can move on from Service Fabric if you wanted to and go to a more sort of like a PaaS offering. So Service Fabric is more on the IaaS side, although it's got some management happening at the service level, but really great for you to, if you have everything containerized, then you can move on to, for example, Kubernetes services instead of using this. Anyway, so it's got really great set of functionalities that you can see on the screen, from lifecycle management to always on to auto scaling, health and monitoring. In fact, Service Fabric is powering quite a few Azure services. So we use Service Fabric ourselves to run our services, and Azure in general, the majority of services are running on top of Service Fabric. It allows you to run your workloads on your on-premises, on other cloud providers, Azure, Dev Machine, whatever, you name it. Just you can run your workloads anywhere, basically. And this could be not only mock services, such as code publishing and other tools, but also containers, so you can run them side by side. The other advantage of this is that you can have, for example, multiple different node pools, and each of those could have their own operating system. So you can basically run Linux workloads and Windows workloads. Historically, Service Fabric was more skewed towards Windows, but now it's got Linux support as well. So here is an example of what's going on behind the scenes. So it's got quite a few different bits and pieces, from a load balancer to node pools. You have different types of nodes. You have front-end nodes, back-end nodes. You can have communication between those nodes to other Azure services. You can have, for example, API. You could use API management to do your ingress. You could, and everything here that we're talking about is directly deployed within a virtual network for you. If you're running it, obviously, in Azure. If you're running on premises, it will be running on your own network. But really great features there. You could basically have direct integration with Azure Monitor, with Azure Pipelines, with Azure Key Vault if you wanted to make sure that your applications are not leaking any credentials anywhere within your system or even within, outside of your system. So really great way to go with that service. So some common use cases that basically we can cover. If you're doing IaaS lift and shift, so if you have a lot of applications which are running on IaaS, or either whether in your on-premises environment, elsewhere, or even in Azure, you could start slowly migrating those into containers. You could mix containers and mock services. So again, as I mentioned, really great way for you to sort of have that particular ecosystem of services running alongside containers. So if you have mock services, there are a lot of different mock services running, and now you want to let a container talk to your mock services or vice versa. You could definitely use this particular feature. It helps you to reduce the impact of noisy neighbors. So it allows you to isolate nodes within your Service Fabric cluster to sort of specify which node can talk to what other nodes, or which container can be isolated, should be isolated, or what node, you're not allowing any particular container to talk to a particular node. So a lot of rules are configurable at that level that you can play with. And then we move on to Kubernetes services. The Kubernetes services in Azure is basically on top of the Kubernetes open source platform. So you have the AKA, and you want to run that in Azure. We've basically grabbed that open source project. We've added our own flavor of integration with quite a few different services, similar to what we've talked about so far. So Azure policies, if you want to do governance, if you want to do integrate with Azure Key Vault, if you want to integrate with VNet, a whole bunch of services on top of what the Kubernetes already provides for you. So here is an example of using a compliance check on your CI/CD pipeline to make sure that the images that are pushed and run within your Aks cluster are already checked and pass a security compliance within your. So really great way again to go through and leverage Azure services when you're talking and when you're making sure that all of your containers, not just in AKS, in all other services as well, have that confidence to run without any particular bug or security hole. It's got support for more than 42 regions and counting, so we are adding more support for AKS throughout different, data centers. It's got basically different environments, so you can run AKS in many different places. There's, public cloud, on premises, IoT edge devices, etc., etc. So really great way for you to access those environments from your Aks cluster, and it's got both support for Linux and Windows operating system as well. So where should we use AKS compared to other services that we've talked about so far? If you want to do lift and shift when you're with your containers or applications, again, this is a great service. Remember, AKS compared to Service Fabric, this is like a fully managed environment. Versus Service Fabric, you have to do a lot of configurations management yourself. So just keep that in mind when you're deciding which service to use for your workloads. If you want to simplify your configuration management of microservices, you could definitely use AKS to overcome that complexity, to have that unified orchestration level on top of your containers, which allows you to have your applications running with ease without needing to worry about the workload and the networking and the trafficking, and everything else is already managed for you. All you need to do is provide the default configuration sets, make sure that you have enough or make sure that you have the proper configuration in place, and then the rest is going to be handled by AKS by default. If you want to bring DevOps and Kubernetes together, again, AKS is a perfect example of that service. You can get the same with Service Fabric. So you can have some sort of a CI/CD pipeline with Service Fabric, but it's not going to be as smooth as what you have with AKS. With default integrations there is pretty amazing. Ease of scaling. So you can enable auto scale. You could basically go in, and we're going to see that in a second. You can enable auto scale, and that will help you to automatically scale to hundreds or thousands of containers running on your AKS clusters. And this is obviously based on the default settings that you go with and how many number of node pools do you have, etc., etc. You could use this for data streaming. So you could use AKS to have, for example, data streaming. This could be, again, similar to what we talked about, again, using Azure Batch and Batch Shipyard. You could use this service to run a variety of different containers, whether it's the long-running operations, data processing, report generation, and a whole bunch of other stuff. You could use this service as well. So let's go through and have a look at a demo for this. So I'm going to show you the creation of a AKS process, but because it takes a bit of a time, I've already created an instance, and we're going to go and deploy our resources to that instance. So first thing first, if I come here and type AKS, I'm going to bring up Kubernetes services, make sure that the publisher is Microsoft, because there are other publishers that have the same functionality there. Here you can see the cluster details. So the preset config. There are some presets that you could select. If you have a look at this, you can see that you have the standard, which is best if you're not sure where to start. This is a great place for you. If you want a dev test, you could go with that. If you want to cost optimize, batch processing, harden access, etc. So these are pre-configurations that you could go and select. All right. A cluster name, this could be anything. So let's say NDC seed. You have your zone. So again, if your zone supports availability, if your region supports availability zones, you could definitely go and set that up. So here, if I choose Australia East, which has 3 zones, you could basically allow that, and that will add resiliency and high availability to your AKS. So your SLA is obviously going up from the default SLA. You have your Kubernetes version, so you can go and use the preview version. I don't recommend using preview version for production environments, but you could use any of the stable versions if you wanted to. Primary node pool, so you can have multiple node pools, but the primary node pool you can basically specify it here. This is simply very similar to choosing a SKU for your VM. So there are different types of VMs that are running that basically power your pods and nodes and everything else, right? You could go and, I'm just going to leave this as default, but you can go and select any of these series of VMs that are available. And these are different purposes. So some of them are designed for handling high CPU workloads. Some of them are really good for low latency and high throughput. Some of them are GPU purposes, storage optimized, etc., etc. So really, depending on your workload and the type of workload you're going to run on your AKS, you can go and choose any of these as well. I'm just going to select the same. Now, you can select the scale mode to be manual or auto scale. This is a really great way for you to make sure that your Kubernetes is auto scaling based on the workload. We're just going to reduce that to 1 because we're not going to trigger that, and that will help us to save some time later on as well. Here you can see the node pool. At the moment, there's the default one, which is based on Linux. You can add more node pools here. This could be a window, so you can run them side by side as well. Again, these are configurations, the maximum number of nodes, pods per node, etc., etc. So you can go up to 250 pods per node, which is quite a few containers to be running within your backend node. Now, if you have agent pools, and let's say your application is now scaled out to the maximum, so there is no more capacity that you could use from your agent pools. There is this concept of virtual nodes, which allows you to use an AKS or ACI instance, or Azure Container instances, to use that as a virtual node. So it will basically use that to create more pods within that service. So that's more of like advanced situations where you might stumble upon something like that. You could enable scale set, for example. You could add authentication using Azure Active Directory, RBAC support. You could actually manage your entire AKS using Azure Active Directory as well if you wanted to. The nodes are already encrypted by a Microsoft managed key, or you can bring your own key if you want to. There are networking requirements. So there are 2 types of networking configurations with AKS in Azure. You could go with KubeNet, which is the default. This will create a brand new VNet for you, and basically you have little or no control over what's happening there. If you already have, let's say, existing VNet, and you want to integrate your AKS with an existing VNet, you will use Azure CNI. And if you choose that, you're going to have to choose your virtual network from here, specify the type of cluster that you have, etc., etc. So this is again up to you. How do you want to proceed with that? You can specify the DNS name prefix, traffic routing, so it comes with its own HTTP application routing. This is good if you have multiple web applications running and you wanted to redirect your traffic from a single endpoint to those backend applications to be able to access them from outside of AKS. There are some integration points here to container registry. So if you want to grab the images from there, you can add Azure Monitor support, Azure policies, as I mentioned before, etc., etc. So all of those are great. And then you go and create your service. As I said, I already created that service here. So this is our Aks cluster. We're going to go and deploy a bunch of resources to this cluster. So I'm going to use Cloud Shell for this. I'm not going to use my local environment. Right. Just going to wait for this. So I'll choose Bash. So Cloud Shell is the terminal in Azure portal. If you don't have access to a service, let's say to a laptop, or you're using your work laptop and you're not allowed to install any software on your laptop, this is the great place for you to run scripts on your Azure environment, right? So we have to wait for this to basically get started. Now, once it's started, this comes with all the required softwares installed. So it's got Kube Controller installed, it's got Azure AKS CLI installed, and a whole bunch of different stuff. So first thing first, we're gonna authenticate to this AKS cluster, right? So we want to make sure that when we run commands against this terminal, it's going to target this AKS cluster. And the way to do that is to use the AKS get credentials command. It passes the virtual, basically the resource group name, so that is NDC Sydney, and we pass it the name, so that is our NDC. What this does is it basically authenticates to this AKS and merges the authentication context into my current terminal. So now if I run commands, let's say we want to run Kube controller commands and get the number of nodes available on our AKS, This command already knows that it has to get this from this Aks cluster. So it automatically detects that we've already merged that context in here. So while this is happening, I'm just going to show you another cool feature of Cloud Shell. Here you have a light version of VS Code. So you can actually edit stuff here directly in your terminal as well. So let me show you what we want to do. So we have this AKS folder here. I have a YAML file, which is the specification file that you use to deploy your services into your AKS cluster. If you're not familiar with that, don't worry about it. You could go and read more on that. I'm just going to keep this very simple. We have two deployments here. We have a backend deployment, which is generally using a Redis cache instance, and it's exposing that through this port. And we have a front-end application. This front-end application is, again, based on this Azure Vault front-end image, and we are just targeting that Redis cache as our backend. And that's about it. In terms of services, the first service for our backend is a private service, so it only gets a cluster IP address, which we call a private IP address. But this one, the web app, is of type load balancer. So that makes sure that there's a public IP address assigned to that particular deployment. So if I now close this editor here, you can see that there's a one node, this is running, and we can now go and deploy this into our Aks cluster. Before I do that, let me show you the services that we already have. So these are some of the pre-configured services here. You can see that all of these are already getting some cluster IP addresses. These are private IP addresses. These are not available outside of this Aks cluster. So we're going to go and deploy our workloads. And if we have a look at the workload, these are the containers that are already running within our Aks cluster. So you have your core DNS for DNS resolution, you have autoscaler, metric servers, etc., etc. So let's go and deploy our configuration into this service. So let me just quickly come here and here. Okay. Back. So if I basically run kubectl apply, so this is the command that we use to tell the Kubernetes to run this deployment, and we're going to pass in the path to our YAML file. So what this does, it will create those deployments for us. I can close this, and if I refresh that, I should have two more basically containers running here. So we have a backend node and we have a front-end node. The backend node should be pretty quick to set up. So there you go. It's already ready and running. It basically, the front end takes a bit of more time because this is now waiting for the service to assign a public IP address to this one. So you can see here the public IP address, and we can access our container through that public IP address. We're going to wait here, and there you go. Our application is now up and running. If I come and bring up this, you can see the application here up and running. So if I vote for cats and dogs, these numbers are now stored in the Redis cache container that we had as our backend. So if I basically refresh this, or if I close this and open it up again, the numbers should still be there persistent. Although our containers get restarted, they could be keeping the data. So again, you can see how easy it is to go spin up a new version of Aks, deploy some containers into it from your container registry or from other places, etc., etc. Now, this is not a simple service by any means, but if you use Aks in Azure, we've sort of simplified a lot of things for you. So this is a PaaS offering, a platform as a service offering. It means that you don't worry about the updates on the operating systems, you don't worry about patch management, you don't worry about security. Everything is handled by Azure. All you need to do is specify what type of workload do you want to run on your Aks cluster. We also have Azure Arc. Now, Azure Arc is not a service which allows you to run containers per se, but it will help you to manage your workloads across multiple different environments. So if you have IoT edge devices on Azure Stack Edge, or if you have your Azure Stack Hub running on your on-premises environment, or if you have some resources running on other cloud providers either, Azure Arc allows you to go and monitor and manage all of that for you. So it's a centralized management layer for all your environment or services, regardless of where they are deployed. Definitely go check this out. Really great service, really great use case of monitoring and management of your solutions using that. So when to use Azure Arc? If you have multiple sites running Kubernetes through centralized management system, you could use Azure Arc to manage all of that centrally. If you want consistent deployments and configurations between all those nodes and clusters, again, Azure Arc helps you to establish that. So basically you have one configuration, one set of configuration, one set of deployments, and Azure Arc will replicate that across all your environments that you specify. Regulatory, compliance, a whole bunch of different stuff can be also applied at this level. And the last thing we're going to cover is the Aks Engine. So we have, of course, we were using the open source software as I told you earlier, but we have also made our version of the Aks Engine basically public. So we've open sourced it, and you can go and grab that open source project and run it even on your local environment. So if you want to leverage the features that are available in Aks, but you don't want to go and start from scratch, you could grab the Aks Engine of Azure and run it in a different cloud provider or even on your on-premises environment. Really great way for you to leverage that as well. Here is an example of running that on a VM. You could use Traffic Manager in Azure to route the traffic to your on-premises environment or to your other cloud providers, etc., etc. But I will use Azure Stack Hub, for example, to run your nodes, and you can have multiple VMs as nodes and all those different stuff that we talked about. So the multiple node pools, different operating systems, everything that we talked about, VNet integration, all of those are available for you to have. So when to use this one? If you don't need, if you need Aks feature, but you don't want to run your containers within Azure, you could use this feature. You could use this service. If you want to manage Kubernetes clusters on Azure Stack Hub, again, this allows you to do so. And that's about it. That's about all the different ways that you can run your containers within your Azure environment. So we have two questions here, two different quizzes here. And before you start anything, we have some swags and we have some Azure Pass subscriptions we can give away. So when we go through these questions, I will ask you to type your answer on my mark. So do not do it now. I will ask you to type your answer. We're going to go through the question and read the answer, and I'll pick a few people that type faster to basically go and grab some of those swags and claim some of those Azure Pass subscriptions. So first question, what is the fastest way of running a container in Azure which gives you ability to connect your on-premises services through hybrid connection? Is it container instance? Is it web apps for containers? Is it service fabric or Kubernetes services? Which one of these is the fastest way of running a container which gives you that ability? I can see some people are basically typing some of the stuff and writing here. Thanks for all of that. I'll wait for a few more people to answer, and then we'll announce the winner. So far, I can see only one correct answer in the chat. Everybody seems to get this. This is a tricky question, by the way, because obviously we have to give swag, and we can't give swag to everybody. So I had to twist the question a bit. All right, so the correct answer to this is web apps for containers. You can't choose container instances because you don't have hybrid connectivity through the hybrid connectivity manager, Azure Relay, using that. So B is the correct answer. So I will choose a few people who have answered B, and thanks for participating in this one. And now to the second question, what two services allow your container to automatically scale based on its workload? This is a multi-choice question. So you can choose two services which allows you to automatically scale based on its workload. Drop your answers in the chat. All right, we got some good answers here. Seems like pretty much everybody has got it correct. So it's B and D. So containers, Azure Kubernetes Services. Obviously, Service Fabric allows you to scale, but the automatic scaling in Service Fabric is a bit different. But definitely, you all have got that correct. So before we wrap up, thanks for participating in that. I will pick up some names from here, and I'll ask you to get in contact with me so I can share how to go and claim your swag and Azure Pass. And you let me know whether you want a swag or you want an Azure Pass, and I will tell you what to do. So from the first question, we have Helen and we have Drex. So Drex, Helen, you folks reach out to me. I'm just going to tell you, reach out to me on Slack. So private message me on Slack and I will tell you what to do. And from the second question, we have Jasmeet and we have Steven. So Jasmeet and Steven, reach out to me on Slack and I will share with you how to go and claim your prizes. So thank you, folks. Thank you so much. If you want to keep in touch with me, definitely do so. I'm on Twitter and LinkedIn. I've got my own personal blog, which I write regularly into. So keep in touch with me through there. Stay informed through our dev newsletter. So this is our dev newsletter, which we publish monthly. It's all about Azure and all the different developer stuff. It's produced and published within Australian branch. So definitely go and check that out if you want to stay informed. And with that, I will thank you all. Thank you so much for being here. Thank you for listening to me for an hour or so, ranting about different things. And hopefully you've enjoyed the talk. Hopefully you've had enough to get started with containers in Azure, and you have, and you can make decisions much better now to figure out what services are there and what to use in terms of your putting a bigger picture or a larger solution together using these services. Any questions, you feel free to put it in the chat either on here or on Slack, and I will go and answer those questions as well. I will put the link to the slides and to the code examples that I've used within the Slack in the room 3. So you can go and grab that. I'll do it in a few minutes. But apart from that, if there's no questions, I will leave you to it, and hopefully you enjoy the rest of the conference, and hopefully we'll see each other face-to-face at some point in future. Thanks, folks.